All right, these two graphs are going to be the continuation of the 4 that I was going to do for graphing when your lead coefficient is bigger than 1. And my video was a little too long, so I stopped it and I started a new video for example number 3. And I have example number 4 down here. So looks like I just forgot my number 3. Who cares? We're going to be all right. Okay, so when you have a quadratic, sometimes you won't have all 3 terms, but the term that you have to have is an a term where you have an x squared, because if you don't have an x squared, well, then you don't have a quadratic, and so you got to have an a. But you may or may not have a b or a c. Those necessarily don't matter, because the quadratic, the x squared term, is what you have a a U-shaped graph. So in this case, my a is 3, my b is -6, and my c here is 0. So first I start each standard form. If you can factor, totally factor, which I'll show you how to get our zeros that way, but I start with my axis of symmetry with that formula, opposite b over 2a. So opposite of -6 is +6. Double my 3 means I have 6 divided by 6, which will be 1. So at 1, I'm going to have a vertical line that will cut my parabola exactly in half, which also means that my vertex will have to hit that line. It has to be on that line somewhere. And let's find where that somewhere is by plugging in the number 1, because I just got one. Okay, so 3 times 1 squared is 3 times 1. You got to do the square part first. Will be 3 minus 6, which will be -3, if I counted right. So here we go. There's going to be my vertex right there. Now, our pattern of change. Normally we go out 1, up 1. Out 2 from our vertex, so like out 2, and then up 4, because 2 times 2 is 4. That's where you get your square piece. Out 3, up 9. But our a this time is 3. So I'm not going to go up the normal pattern. I'm going to go up triple that pattern, because my a says triple your x squared. So I'm going to multiply this by 3, and I'm going to get 3. Multiply this by 3, and I'm going to get 12. Multiply this by 3, and I get 27. Now my a is 3, which is positive, so we are going to go up as we go. So this graph is going to open up, and to find your zeros, I didn't do this in the other videos, but you can always factor and set your factors equal to 0 to get your zeros. If 3x was equal to 0, your x-intercept should be 0. And if x minus 2 was set equal to 0, your intercept should be 2. So I know at 0, 0, I got a 0, and at 2, 0, I got a 0. So 0 and 2 because of my factors. But notice, if I go out 1 and up 3, that's my next point, which is 2, and out 1 up 3, I get my other 0. So I could have done it with my pattern of change or factoring. So just kind of, you know, what works best for your brain, I don't know. You got to do what works for you. Okay, now, out 2, we normally go up 4. Okay, but I'm going to go triple that because my a was 3. So we already went up 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It's going to go out 3 and up the same amount. And that looks like, to me, that's as high as we're going to be able to go, because I cannot go up 27. That's way too far. And so there's my picture. My y-intercept, where it crosses the y-axis here, is always the c value of your function, which was 0, and my minimum, because this is the lowest point of my graph. You want to report the y value. And the y value of my vertex, the lowest the graph reaches is -3, and it goes up from there. And that just kind of helps you with, call it range, the range of your graph. Y is always greater than or equal to -3. You might see it like this, -3 to infinity. All real numbers greater than or equal to 3. So your min and max can help you identify your range, like domain and range of your function. Okay, last one. Whew, I'm getting a little quicker as we go, which is exciting. So the video hopefully won't be as long as the first one. Okay, so here we go. My next graph has a coefficient of 4, and we haven't done one of 4 yet. So my A is -4, B is -8, and the C value, your linear term, I don't have one. And so again, y-intercept is that C value is going to be 0 because we don't have one. And then I'll show you again why I get that when I factor. I start with my axis of symmetry, which is from the formula opposite B over 2A. Opposite sign of -8 is +8. And we'll divide by double our A term. So I get 8 divided by -8, which is -1. And that is my vertical line where my graph, negative. That's the vertical line where my parabola is going to alternate perfectly on either side. So my vertex is going to cross through -1 somewhere, and I'm going to find that somewhere by plugging that value in. Okay, -1 times -1 is 1, and a -8 times -1 is an 8, and 4 plus 8 is 12. So I got -1, 12, all the way at the top of my grid here. And now you can find your zeros by factoring. So my function was -4x squared minus 8x. I notice both of them are divisible by a -4 and a letter x, 2 here. So if I set this factor equal to 0, 0 divided by anything is 0, and I get -2. So I know I'm going to have a factor here, and here. And I'm looking at this, I'm noticing something isn't quite right. There's no way this can be 12, and I see I made a mistake. I'm actually glad I'm doing this live with you. Isn't my A negative? Do you see I forgot that negative symbol there? I hope you picked up on that and you're like, Miss D, what were you thinking? Eliminating a sign, you can't do that. This would be -4 times 1, which should have been, I was thinking, it can't go down 12 right away because we were at 12 and it went all the way down to 0. No way. Our A is only 4, and this is actually going to help us here. It should have been 4, 1, 4. That one negative sign, I'm glad I caught it. So my vertex is not at 12. So let me get my favorite tool in my toolbox, white out when you use anything other than pencil. Should have been at 4, which now I'm thinking makes more sense because our pattern of change that we talked about in each video. If I go from my vertex out 1, normally you go up 1, and if you go out 2, you go up 4, 3 up 9, 4, 16, and so on, your squares. But in this case, my A is negative, so we're going to go down. So opens down because my A was negative. And it's -4. So I don't just go down 1, I'm supposed to go down -4. So I multiply these together. And I'm not supposed to go down 4 when I go out 2. I'm going to go 4 times that amount, which would be down 16. And then I'm not going to go down 9 when I go out 3. I'm going to go 4 times that amount, which would be, oh gosh, 9 times 4, down 36. Okay, and so I know my pattern of change. I knew something was off because I knew I wasn't going to go down 12. No, I knew I was going to go down 4. So this makes more sense. All right. My zeros I can see now on my picture, and I calculated them here, 0 and -2. And this is going to be the max of my graph because my graph opened down. The y value is what you report here. The highest it's going to reach is 4, and it will always go lower than that. So here we go. You can make a t-chart. You can plug in -1, that was your vertex, and we already know that was 4. And then plug in 0, 1, and 2, a couple numbers to the right, a couple numbers to the left. Or you can use your pattern of change, and I just like doing the pattern of change because it's, for me, faster. But you can always plug in, kind of like what we did here when we plugged in -1, do it again and plug in 0. Do it again and plug in 1. Do it again and plug in 2. Or use your pattern of change. We're not going to go down 1, we went down 4. And then out 2, we're not going to go our normal rate 4, we're going to go 4 times that amount, or 16. And I have a feeling that's going to be off my grid, but let's count. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, oh, 16. I'm surprised, but not surprised, because normally I would do something like that to help myself out. Those are going to be on the last point here. So 1, negative 12, 0, 0, negative 2, 0, and negative 3, negative 12. If you were to have made your T-chart, that's where you'd get your points. And that is your parabola that goes down 4 times as fast as a normal quadratic.